Here we begin the second video about onto functions. We will discuss a method to discover non-onto functions. Recall that a function f from a set A to a set B is onto if and only if this quantified statement happens. For every y in the codomain, which is B, we can find x in the domain such that f of x is equal to y. And that means a function f from a set A to a set B is not onto if the negation of this statement happens. That means I can find at least one y in the codomain such that this y is not the image of any x in the domain. So for every x in the domain, f of x is not equal to y. We also say that if we have a function f from a set A to set B, to know if it is onto or not, we do a working backward. So we assume y in B, and then we find a solution x which satisfies these conditions. Y is equal to f of x using the formula for f. If we can find x in the domain for every y in the codomain, we have a proof. If not, we get a counterexample. And this video is about finding these counterexamples by working backwards. As an example, show that the function f defined from the set of integers to the set of integers defined by the rule f of n is equal to 2n plus 1 is not onto the set of integers. By inspection, you can notice that the image of any integer here is 2n plus 1. That means the image is an odd number. So the range of f is a set of odd integers. But we will give a systematic way to know how this function is not onto. As in the proof of a function is onto, we do working backward first. So I will take m to be an integer, and we'll say that m is equal to f of n for some integer n. That means m is equal to 2n plus 1 by the formula of f, which gives me that n is equal to m minus 1 over 2. Now for the function to be onto, this number n have to be in the domain, but the domain here is a set of integers, and m minus 1 over 2 is not always an integer. So n is not always an integer, and so it is not in the domain always. For example, when m is equal to 0, then n will be minus half, which is not an integer. So this m equal to 0, which is in the codomain, will be my counterexample to prove that f is not onto. So the solution for this example will be a proof by contradiction. So we assume that the range of my function f is equal to a set of integers. Then for 0, we can find an integer n such that 0 is equal to f of n equal to n plus 1, where n is an integer. But then, solution of this equation for n give n is equal to minus half, and minus half is not an integer. So it is an integer, n is an integer, but in the same time n is not an integer. They give me a contradiction, and that means my assumption is wrong, and so f is not onto the set of integer. Now we have to say that not always you need to work backward. For example, this function here is simple, and we know that the range of f is a set of odd integers, and so without using working backward, I can take any even number and then prove a contradiction. So I can assume that in the solution, assume that the range of f is equal to z, and instead of taking 0 and take any another even number, for example, I can take minus 2, and setting minus 2 is equal to f of n is equal to 2n plus 1. That means n is equal to minus 3 over 2, which is not an integer, and this gives me a contradiction. However, working backward can give you a solution for complicated functions. We take another example. We want to show that the function s defined from the interval from minus infinity to 0 to minus 5 infinity, defined by the image of any x in this interval, is equal to x squared minus 4, is not a surjection. So I do working backwards. I assume y in the codomain. So y in the interval from minus 5 to infinity. And I assume that y is equal to s of x, where s of x is x squared minus 4. And that means x squared is equal to y plus 4. Now we notice here x squared is positive, and y plus 4 is going to have to be positive. But y is greater than or equal to minus 5. This value is not always positive. That means this x squared sometimes cannot be in the domain. As an example, when y is equal to minus 4.5, minus 4.5 is in the codomain, but then x squared will be minus half, which is not in the domain of my function s. And this will give me a contradiction, which means that minus 4.5 is not in the range of my function. And so I found a counterexample. My counterexample will be y equal to minus 4.5. So in the solution, I will take y is equal to minus 4.5. Then y is in the codomain of my function s. And I assume that y in the range of s. Then we can find x in the domain such that y is equal to f of x, because y in the range, I can find x in the domain such that y is equal to f of x. But using the formula for f, that means x squared minus 4 is equal to minus 4.5. And thus, hence, x squared is equal to minus half. But that means x is not a real number, because for all real numbers, x squared is non-negative. And that means x is not in the interval from minus infinity to 0, which gives me a contradiction. So x here in the interval, but here is not, and this gives me a contradiction. That means my assumption that y in the range is wrong, and that means s is not a surjection. This ends the second part about onto functions.